Hi, I'm Steve and I'm here at the Digital Library at Newcastle West, and I'm going to talk to you about 3D printing. And the best thing about 3D printers is they bring designs to life. And I've got a couple of examples to show you. What I have here are some simple 3D prints. This is something I designed myself. It was a component that I couldn't purchase, so I simply designed it using some CAD software. And that is as it was printed. I did no finishing on that, and it was designed to sit inside that with that aluminium extrusion and be part of an assembly to hold some batteries in a power supply. The other thing with 3D print designs is you can download them. Here is an example, actually from a cycling magazine. This is a component that wraps around the crank on a bike, so the pedals are here. And what it does, when it's fitted into place, it holds some cables away from the crank. So somebody designed that up as a solution to a problem with cables rubbing on the crank arm and put that out for everybody. So simply by downloading and printing it, that just went straight in the bike. Here are a couple of examples. Another one. This was from a computer magazine, and what it enables you to do is to mount a motherboard inside a very small profile case. In order to do that, the fan has to be moved and sit right up against the heatsink. So the fan is simply bolted onto this and clipped onto the heatsink. The beaut thing about it is, once you've made one, you can make many. So, and the fact that you've got the file on print means that if something happens in the future and you need to make another one, or you might come across somebody that needs one, you can simply get that file and put it through the printer and you're good to go. All 3D printers use a similar mode of operation. Basically, and the best way to explain it is to think of a glue gun. Everybody's used a glue gun at some point. Quite simply, the glue stick mounts in the back, there's a heated segment, and you pump the glue through. If you could imagine holding it in a vertical position and pumping glue out of it as you moved it along, you can create things. You can create shapes. Now, you don't normally use a glue gun for that purpose. However, it does explain the fundamentals of how a 3D printer works. So what I've explained is the fundamental principle called fused deposition modelling. And all the printers that the library own work on that principle. The image behind me indicates all the major components of a fused deposition modelling printer. Over here we have a spool, and that has on it some filament. It looks like really thick fishing line, and this can be all different sorts of plastic material with different characteristics and different melting temperatures. From the spool, it is fed or is drawn through this pinch and roller system. That's essentially the feed mechanism for the filament. It is then forced down into a hot zone or a heater. Think about the glue gun. This is really a glue gun. So the filament is forced down through the heating zone, it melts, and then it is extruded at a much finer diameter as molten plastic onto the job that's being printed. Now, the way it's being laid is that what we call the platen at the bottom that the model is being built on is moving in an X and Y pattern. So that's how it describes the shape. Now, the 3D printer works on layers. So each layer is fully printed, and then this whole system moves up by a very small increment. And then the process is repeated. So essentially, it's building up the model as a series of slices, which are all fused together. One of the things that the 3D printer can do is build up a solid skin and then alter the density of the print as well. That's an important factor in making prints light. What I have here is essentially the view from a website called Thingiverse. The website is maintained by a printer manufacturer called MakerBot in this case. And what you can do is basically search for all sorts of things, potential solutions you may be looking for, and then have a look at a whole suite of pre-designed things. The next thing I'd like to talk about is that you can print the impossible. What I'm holding here is a cube. It's sealed on all four sides. However, it's not like that in the middle. If we take a series of cuts through it, it'll actually reveal that the interior of it is a sphere. So this is the beauty of 3D printing. If you have a volume that you don't really need, if you're just looking for a shape, you can make things hollow. And it would be impossible by any other means to make something like this. And the only way I can prove it to you is that during the printing process, I dropped a small piece of metal in there, so it rattles, thus proving that that's the internal shape. So that's the other thing about 3D printers. They are sending manufacturing in a completely different direction because they can do the impossible. What's shown behind me is an actual 3D printer. Going back to the earlier description of how the fused deposition modelling system works, this is extending now to how the printer itself works. What we see is the print head up here. This is the drive system, the pinch and roller system that takes the material in at the top. That's the actual print head with its very small extrusion hole. Down the bottom is the platen on which the print will start to be created. And we can see here we have a drive motor and a belt. So that moves in that direction, the X direction this way. The print head is also supported on two rails, and there's another drive belt and motor here. So that moves in the Y direction across. So we have our X and Y directions in place, and they're exactly at 90 degrees to each other. The next thing is, as each layer is being built, the print head will start very close to the bottom and extrude a base layer. And then, as each layer is built, there are two jacking screws, one on this side and one on this side, and they lift this whole assembly up in very fine increments, possibly as low as 0.1 of a millimetre. Now, the image behind me shows the complete process of creating a 3D print if you design it yourself. It's probably not the best place to start, but it's a good place to end if you have your own 3D printer or you're using the facilities here at the library. So, like all designs, it has to start with an idea. And that idea is translated to a design using 3D modelling software. So that's where the design or your creation is digitized. That will then export a particular file format called an STL file. Now, an STL file is the same file format that you would download from the web. That file is then read by what's called a slicer, or some slicer software that you would also have to have. And what that basically does, it takes your three-dimensional design, let's take this for example, and it takes that external shape and it essentially makes up all the information, all the data file to print that layer by layer. From the slicer, what's exported is a file called a G-code file. G-code is a universal machine control file format. It's used for all sorts of machining processes, but in particular, in this particular application, it's got file instructions unique to the 3D printer. Then that comes across to some printer control software. Now, in my case, that resides on a laptop that talks to the printer. On some other machines, they can read the G-code file directly and print it. So But this is always a step in the process. It then, these printer commands are what the 3D printer uses to work. And at the end of the process, you remove the print and you've got it.
Hi, I'm Paul. I work for Newcastle Library and I'm here today to talk to you about our 3D printing service. So as Steve mentioned to you previously, you can send us your file that you may have modelled in an STL format if possible, or you can download one of the STLs in the world. There's thousands and thousands of them available. There may already be design that you can just download and print without having to worry about designing. That's step one. Step two, email the design to the library. I'll put up the email address in a moment. Step three, agree to the quote and the materials we propose to print your file in. If you agree to the quote, then the library will print the item for you in a timely manner, and when it's ready to be printed, you can collect it from our reservation or hold shelf at the library of a branch of your choosing, so it works just like a book or something else you might put on reserve. So here's a 3D printer in action. It's working, and I'll point to some various parts. So here's where the filament comes in to the extruder and the hot end. There's two sorts of filament on this particular printer. It's a pretty high-end one. Got a normal filament feeder here, but this thin one here will feed fiberglass, Kevlar, and some very high-strength materials to give the 3D prints a lot more strength, so you can apply them in the real world without them breaking, snapping, or falling apart. So you'll notice that the print head is moving along two axes, X and Y, as they're called, and the print bed does the Z axis moving. So whenever a new layer is deposited, the bed will move down just slightly, 0.1 of a millimetre to about 0.3 of a millimetre, depending upon the resolution of the print, and then a new layer is deposited on top. So if you do want to send a 3D print to us, here is the address, libtechsupport@ncc.nsw.gov.au, and we'll get right on it. Thanks very much.